Right now, without you thinking about it, your body is running dozens of tiny correction systems. Your temperature, your blood sugar, the acidity of your blood, all being nudged back into line, second by second. That balancing act has a name, homeostasis, and today I want to show you exactly how it works, because once you see the pattern, you'll spot it everywhere in biology. Homeostasis just means keeping a stable environment inside your body, and here's the key idea. Your body isn't aiming to hold things perfectly still. It's aiming for a set point, the ideal value, like a core temperature of about 37 degrees Celsius. Around that set point, there's a normal range, a band it's allowed to drift within. Small ups and downs? Totally fine. But drift too far and your body kicks in to pull it back. So the real question is, how does it do the pulling back? Every feedback loop in your body is built from the same three parts. First, a receptor. It detects the change. Second, a control center, usually the brain or a gland. It decides, comparing what's happening to the set point. Third, an effector. It responds, actually doing the thing that changes the variable. Detect, decide, respond. Receptor, control center, effector. Lock those three in because they show up in every single example that follows. Let's watch it run. Say you go for a run and the body temperature climbs above 37 degrees. That's the stimulus. Thermoreceptors in your skin and brain detect the heat. Your hypothalamus, the control center, compares it to the set point and says, too hot. So it fires up the effectors. You start to sweat and the blood vessels near your skin widen to dump heat. Your temperature comes back down. Notice what happened. The response opposed the change. That's negative feedback. It reverses whatever knocked off you balance. Same pattern, different variable. You eat a meal, your blood sugar rises. The beta cell in your pancreas detect it and then release insulin. Insulin tells your liver and body cells, the effectors, to pull glucose out of the blood and store it. Blood sugar drops back to normal, and as it drops, the insulin signal switches off. Same three parts, same reversing move. This is the workhorse of the body. But there's a second flavor of feedback that does the exact opposite, and it's wilder. In positive feedback, the response amplifies the stimulus, pushing things further and further. Take childbirth. The baby's head stretches the cervix. That stretch triggers the hormone oxytocin, which makes contractions stronger, which stretches the cervix even more, which releases even more oxytocin. It snowballs, on purpose, until the baby is born and the loop finally stops. Blood clotting works the same way. Activated platelets call in more platelets, which call in even more, rapidly sealing the wound. Positive feedback isn't about balance, it's about finishing the job fast. So why is almost every system in your body negative feedback? Because life depends on staying stable, and negative feedback is what holds the line. Positive feedback is powerful, but dangerous. If it ran your body temperature or your blood sugar, a small change would spiral out of control. So your body saves it for rare one-time events that need it to happen quickly and then stop. So here's your cheat sheet. Homeostasis keeps a variable near its set point. Every loop has a receptor, a control center, and an effector. Negative feedback reverses changes to keep you stable. That's the default. Positive feedback amplifies change to drive a process to completion. Next time you break a sweat or feel steady after a big meal, you'll know exactly what your body just pulled off. If that clicks, subscribe for more, and I'll see you in the next one.